Hello all, very good morning. Thanks for joining the session. Let me share my screen. So yesterday we discussed about the monolithic application and then the disadvantages of the monolithic application or the problems that we will face in the monolithic application and the solution, how the microservices were given for the problems that we have in the monolithic application is what we have seen yesterday, isn't it? So this is what we discussed yesterday. What are microservices, right? So microservices are small, tiny applications which will be self-executable, independently deployable, and autonomous. So what is autonomous? Each and every microservice is having their own JRE JDK with respect to a specific business functionality, which is called as single responsibility per service, isn't it? So these are the things that we have discussed yesterday. And today, let us go and then continue discussing. Today, let us go and then continue discussing about the microservices evolution and the microservices characteristics and then principles. Very important. Without understanding the microservices characteristics and then principles, and without applying the characteristics and principles, we cannot design or we cannot develop the microservices. However, let us see now how the term microservices was derived or came actually. So the term microservices, just let me check. One moment. Hello all. How is it now? Am I audible properly now? Yeah.
Yes, yes.
Okay. Yeah. So now let us see the microservices, how the microservices were evolved, and what are microservices. What are microservices is just a simple definition we have seen, but how the microservices were evolved, let us see today. And the most important point is the microservices characteristics and then principles. Let us try to understand with the honeycomb analogy, meaning the microservices concept. Let us try to understand with the honeycomb analogy, and then let us also understand the principles and then characteristics of microservices. Very, very important. And then the 2 principles plus 6 characteristics should be in our mind whenever the interviewer will ask actually. However, let us start discussing about it. So Martin Flower explains the term microservices. Actually, term microservices came, Martin Flower is the person who conducted one workshop all over the world by inviting the software architects across the various IT industry domains and all. In Venice in May 2011, he conducted one workshop of software architects, and in that workshop he asked the architects that what are all the common problems that you are facing in your applications. So that is the question he asked to all of the software architects, and they have discussed a lot So many members told, whatever the problems they were faced and all. And Martin Flower said, let us take 1 year, like 2011 we gathered, and then let us take the same month, that is in May 2012, let us gather, and then let us come to a final conclusion, and then the solution for the problems that we are all commonly facing in the IT. That means, commonly facing in the application architecting, or the application commonly we are facing the problems. So software architects all over the globe went and then came back in the next year, that is May 2012. The same group, the persons, the software architects again gathered in the year 2012, and the problems they were explained, right? The common problems what we are all facing in the application designing or application architecting, or a common application, a simple application, or maybe a complex application. Usual problem is what, usual problem is what, the performance of the application. A very common problem is what, performance of the application. A very common problem. So how the performance issues of the application will be, rectified or modernized, that depends on the number of modules that the application have usually. So no matter how many modules were there in the application, but if we want to have a, a much performance oriented application, then what we need to do, we need to follow the divide and then conquer policy. So divide and then conquer policy is what we will divide the application into small pieces, and then we will connect all those modules together. That is called divide and then conquer policy. So these are the problems, and then the solutions the architects are using was explained to Martin Flower in the year 2011 workshop. Then Martin Flower asked the guys, actually, okay, in divide and conquer policy, in divide and then conquer architecture rule or the policy, whatever the steps we are following, or can we generalize it to some kind of an architecture? So that question he was asked the software architects. Then the software architects were done the research and all, and they again were gathered back in the May 2012, and then all the folks were came into one single word. Yes, we were find out a generalized architecture, and let us name that generalized architecture as a microservices. Then the generalized divide and then conquer architecture has been renamed as the microservices by applying few more concepts to that, few more concepts, few principles, few characteristics. So they defined one standard. Microservices meaning microservices should have these principles. Microservices should follow these principles. Microservices should follow these characteristics. So they were defined the characteristics and the principles to the divide and then conquer architecture, and then renamed it as the microservices. Thus, the term called microservices was given by the Martin Flower in the year May 2012 in Venice Software Architects Workshop. Got it? Two things I am talking here very specifically. What are those two things? Divide and then conquer policy, or divide and then conquer architectural design has been reshaped by applying the few characteristics, few principles, by writing or by suggesting few characteristics, few principles. The divide and then conquer, the divide and then conquer design or the rules, the divide and then conquer policy has been renamed as the microservices. So maybe you're curious to know what is the divide and then conquer policy, isn't it? Just let me type divide and then conquer, divide and then conquer architectures. Yeah, let me open this just in case to showcase you. Let me open this divide and then conquer application architectures. How it will be. Sorry, this is not divide and then conquer applications. Yeah, so yes, usually this is kind of the algorithm series, divide and then conquer algorithm. So problem, split the problem into small subproblems, split further the subproblems into computer subproblems. So these subproblems were grouped together or combined together will provide a solution basically, right? So divide and conquer meaning divide it to a smaller pieces and then conquer them again back to form a larger piece. Got my point, right? See this. This is one more thing. Problem, divide into subproblem and conquer solution to subproblem. And there is again problem, divide into subproblem and then solution to subproblem. So combine these two solutions to a problem for this solution. This is exactly divide and then conquer, right? So merge sort algorithm is providing it. But however, this is the concept of the divide and then conquer. What is happening here? You know, a bigger problem is dividing into small problems, right? And then applying the solution to all small problems, and then combining all these solutions so that that becomes a solution for a bigger problem. So this is called what actually the divide and then conquer policy. So here also you can see problem size of n, subproblem of size n2, subproblem of size n2, smallest possible subproblem, smallest possible subproblem. So solve the problem. So solution of subproblem of size n2 for this one. See, bigger problem divided into small subproblems. Again, subproblem divided into small subproblems, smallest subproblems. Provide the solution for the smallest subproblem and then conquer them. Finally, it becomes a solution of a original problem. So this is what the divide and then conquer policy. So this divide and then conquer policy was used by the software architects to address the performance issues, like how dividing the application into small modules and then correlating or connecting or combining all the modules into a bigger application. So that is what the software architects followed in the divide and then conquer policy. So divide and conquer, divide and conquer policy. So in divide and conquer, in divide and conquer policy, right? The queues application with so many modules, will be divided into a small modules. A huge application with so many modules will be divided into independently executable modules, meaning small modules, and implement the code and implement the feature or use case, and again combine all such small modules together to form a huge application. So this is what there in the divide and then conquer policy. So microservices were evolved. Microservices were evolved. Microservices are not invented. Microservices is not a new thing. Rather invented, microservices were evolved. For example, Java is invented, right? Java is not evolved. Java is invented. Somebody have started writing the Java programming language. So it is invented. But microservices are not invented newly. Microservices concept is already there, divide and then conquer policy. Just by applying the few characteristics, just by applying the few policies to this divide and then conquer policy, the microservices were evolved. So microservices were evolved by applying the principles and characteristics to the divide and conquer architectural applications. Divide and then conquer architectural applications. You got my point, right? Microservices were evolved by applying the principles and characteristics to the divide and then conquer applications. First of all, we need to, I believe you might now got little idea about the divide and then conquer applications. Just in case, let me draw something now. So here is a huge application. Here is a huge application. So this huge application, you can see in this document as well. So we have a huge application. One moment, let me show that. Yes, see this application. So this is a huge application, a bigger application. It's too big. Let me display. Yes, if you can see, this is a bigger application, right? So this application having what actually, you can see the boundary. This application having the presentation layer, business layer, database layer, module A, module B, module C. So module A having the module A, presentation layer, module A, business layer, module A, database. And module B is also having module B, presentation layer, module B, business layer, module B is also using the same database. And module C is having the module C presentation layer, meaning the controller, maybe business layer, meaning the services, and then the database, meaning the DAOs and all, right? So all these modules, presentation layer, business layer, and then data layer, all these modules having this presentation layer, business layer, and then the data layer. Now in divide and then conquer policy, what we will do, carefully observe what we'll do, we will do like this. So in divide and conquer policy, what we will do, carefully observe, we will do like this. Just carefully observe. Yeah, just carefully observe. What we'll do is, let me take this one. So what we'll do, this in the divide and conquer policy. I'm not able to draw something, but let me take this one. If I could be able to draw something. Just in a moment. Okay, so in divide and conquer policy, if you can see, we will divide it into something like this. So this piece, right? So this is one module, and we'll divide this into another piece. This is module B. So we'll divide this into another piece, which becomes the module C. So got it right? Otherwise, let me try to draw something if I could be able to. So what we will do is, I'm not able to draw the things here, but just let me try to draw something. Okay. No, not able to. Okay, but you just analyze the case. This is a huge application, isn't it? In divide and conquer, what we will do? We'll divide this entire thing. I got it. So what we'll do? This, just take this one. So this as the one module. So we'll divide this as one module. Okay, and also we'll take this as another module. Carefully observe. So this as now another module. So we divided the modules. So this is module A, and then this is module B. Observe module B. Now we'll also divide the module C. This is what the module C. Yes, this is what the module C. Now we have the module C, and we have the module B, and then we have the module A. Now the application divided into 3 modules, isn't it? 3 modules. So you may have one question, sir, already we have this, right? Every application is divided into modules. But what I'm saying is, each and every module here is one application, is what I'm talking about. In divide and then conquer policy, we will divide the module as one separate application. So this is that module. And we will divide the module B into separate application, module C into separate application. And these 3 modules will be grouped together, right? By taking the complex Marvin architectural application. So what I mean to say is, just let me explain you this case. Just give me a moment of time. Let me explain you this case. Our architectural document, let me open this. Just give me a moment. Let me open one of the architectural document. I can showcase you how we can take this divide and then conquer policy. Just give me a moment. Design considerations. So these are all the documents I'll provide. So microservices design considerations. Let it upload. Yes. Scroll down. Not this one. One moment. I would like to showcase you the Marvin complex architecture, not this package by feature. Yes. Marvin multi-module versioning. So by using the concept called Marvin multi-module versioning. So we will do in the divide and then conquer policy, the huge application is divided into a sub applications or small applications like this. So module A, module B, module C. Now what we will do, this module A is one project. So module A is one project. So this is module A. Module A is one project. Sorry. Yeah. So let me take one new data type. Maybe you will get an idea. So what I mean to say is the huge application which is having the lot of modules is divided into small applications, and these small applications will be again combined together. So Marvin multi-module architecture. Marvin multi-module. Let it open. So what I'm saying is the huge application, this huge application divided into the modules. So this is the huge application. So this huge application divided into these modules. Right, so these are all the modules now. So this huge application divided into the modules. Perfect, right? So this is module A and this is module B, sorry. So module A, module B, and then module C. Now we were divided the modules of the application into modules of a main application into small applications. This is the application A or module A application. So form.xml of the module A, form.xml of module B, form.xml of module C. Now for all these three modules, there will be another form.xml file. So parent form.xml. Right now, what will happen when we build the parent application? The projects also get built and then form a single var file. Right, form a single var file. That means this architecture were formed. You got my point, right? So this is called what actually? Divide and then conquer policy. Let us do this actually. Practically, let us try to implement it. And for this divide and then conquer policy, we will apply the characteristics and principles. Then we will, derive the microservices. So what we need to do first in the Marvin multi-module versioning, first let us create the one application. Okay, so let us create the one application. Let me create the one application called Shopify platform is already there. So let me take one Marvin project. Okay, I will glance you the document first. So the parent POM project pom.xml file holds the version information of the parent project. So this is what the version information of the parent project. So don't mind about these packages because when I was in another institute, I prepared this document. That is the reason you see these packages, but don't consider it. So this is the parent project. Now the child module POM contains a reference to the parent information. So parent by parent and then the child project. So this is what Marvin multi-module versioning. So what we can do now, so let's see, let us create one project, one main Marvin project. Let us take. You are getting my point, right? What we are doing, we are practicing the meaning. Practically, we are seeing the divide and then conquer policy. So group ID is com.soft. Artifact ID is the Medilab app platform. Medilab app platform. Let's say we are building the this is form actually, right? So this is the form actually. Now what I will do is finish. So let the project be created. So it is taking little time. Let it create. Yes, the project is created. Medilab platform. Wrong actually. Let me take it as a var file because a huge war file need to prepare, right? From the sub modules, a huge war file need to prepare. So what I will do is, let me take a Marvin project again, and then the create a project. Next, com.dsoft, and then this is the middle app preclinic app, and then which contains the sorry, not POM, which is a var file. Finish. Now let the var project be created. Middle app preclinic app. Okay, now the var project is created. So there is a POM and there is a target, right? So if you can here, this is the project, we got it. Now pom.xml file contains, yeah, so project, group ID, packaging and all, right? So let us go to the documentation and then see. Yes, group ID and all. Here packaging is, let us take as a POM, not var file. Let us take the packaging as a POM. WebXML is missed. So let us add the fail on missing is equal to. Okay, let me take one more project, new, other, Marvin project. This is the create simple project. Next, com.dsoft, artifact ID is what you know, middle app parent. Parent, let us take whose application type is POM. Let the middle app parent be created. Okay, middle app parent is created. Now here the parent application will have pom.xml file. This is POM actually. Now what we can do, this is the middle app preclinic app. Let us say middle app preclinic backend. Okay, and similarly what we'll take, middle app preclinic front end. One more application let us take, which is middle app preclinic front end. Front end. Right now front end is there, back end is there, for which the middle app is parent is the parent. So what we can do, group ID, and this we will take as a parent. So go here, go to pom.xml file, and here packaging is var, and let us take the parent by parent. Parent by parent, and here let us add this one. That's it. Right now this group ID is already deriving from the parent, and then the version is also deriving from the parent. Now let us see. Perfect. Right. So what is here? WebXML is missing. That's okay. Let us add one properties. Property. Let us disable this issue, meaning fail on WebXML is. Let us set it to fail on WebXML false. Don't fail. If the WebXML is not there, don't fail. Right. So this way the issue will be resolved. Now similarly, let us go to the application called the front end. Right. So go to the pom.xml file. Now for this front end, the parent is same, isn't it? The middle app parent is the parent. So let me copy till parent by parent and then write here. So parent by parent. Right, save it. Now this group ID is deriving from the parent, version is also deriving from the parent. Now done. Right. So front end is there and then the back end is there. These two, for these two applications, right? Who is the parent? This middle app parent is the parent. Now let us build this middle app parent. So run as Marvin clean. Run as Marvin clean. Yes, Marvin clean plugin. And we also need to apply few more plugins, but that's okay. Let us install this. Because these two should be combined as a single, right? So what we can do, in the parent, we have to represent module by module, right? So here we have to represent modules. Inside these modules, we have to say module by module. And inside this module by module, let us check.
Sir, front end and back end content are having parent. What is that meaning exactly?
I'll explain. So this application, let me check. Yes, this is the backend, right? So this is the backend application, meaning which contains the backend code, meaning the controllers, services, DAO logics and all, right? So this is the backend, and this backend is extending the parent. That means what? Whatever the common things are there, we will put in the parent, and those will be derived to this child project called the middle of preclinic backend. Got it? Similarly, here
So
also
kind of inheritance, right, sir?
inheritance, correct? That is true. So now here also we have the middle of preclinic front end. So middle of preclinic front end. One moment, guys. Middle of preclinic front end, whose packaging type is var, and whose parent is again the form.dsoft. And this also here we will face one problem, that is properties by properties. Let me add this properties by properties. That's all. Now what happened? This is the front end project, and the other is the back end project. These front end and then back end are using the parent, same parent, and in the parent, let us define these are the modules. In the parent, let us define these are as the modules. See this, the parent. Now see this. Now the parent project dependencies will also be resolved to the child project through the child project doesn't have any dependencies configured. So what we can do now, go to this parent project, and in the module, let us configure. This is the one module, right? And similarly, let us also configure what is the other module. Front end and then the back end. Exact artifact name, let us give as the module here. Go here, and then here let us give the backend. Perfect. Now what happened? The parent project is there. So if we can go here, let me draw the diagram. Go here. Now what happened? The parent project is there. Here is the page parent, right? And this parent project is having the modules as two sub projects, right? So these are the sub projects. So one module is the backend, right? One module is the backend, and another module is the front end. So this backend having the form.xml file, right? So front end also having the form.xml file. So backend have the form.xml file, front end module also having the form.xml file, and parent also having the form.xml file. This is the parent. Got it? Now let us go and then build the parent. Automatically childs also get built. Let us go and then clean, Marvin clean. Now only one var file should have to be created for the middle of parent. Let us check. Error. What is the error? The project com.middle of parent snapshot personals has two errors. Middle of parent form.xml does not exist, and then middle of parent form.xml does not exist. What is this? Let us say middle of parent, middle of preclinic, and then middle of preclinic front end, preclinic backend. This form.xml does not exist. Okay, we will do one thing. What we will do is first let us build this one. Okay, let us insert. Let's see. build could not be read the information. Okay. So what we will do, these projects, let us try to put under this. No, actually, these are creating as this front end. One moment. What I mean to say is this middle app parent is there, right? Inside the SRC of the middle app parent, you can have these applications. So, but these are creating it outside. That's okay. What I will do is let me go to this parent. Okay. Now in this parent, let us add this backend. Perfect. And let us add the front end. Okay. Now exactly in this backend, where is the parent pom.xml file? We have to mention the parent pom.xml file as well. That means what I mean to say is, in order to have a build, what we can do is inside this pom.xml file, we need to mention the location of the pom.xml file. Okay, and here also we need to mention, yeah, this is one. // meaning what? Here is the pom.xml file, right? We are going one step back and then going here and then taking this pom.xml file. Let us check whether this will, take or not. So take the relative path and then // .xml. Fine. Now what we will do is let us go and then build this. Okay, not here. Let us take the relative path here. Relative path // pom.xml. And also let us open this backend and then take the relative path // Makes sense? Now let us try to build this middle app parent. Run as Marvin clean. Let us check. See this build of the application is done. Middle app parent success, middle app parent front end success, middle app pre-cleaning backend success, right? So application cleaning is success now. Then
Sir, why we created inside this middle app parent?
Yeah, why we created is because the pom.xml type is what? Packaging type is pom. Okay, so we even can take here also, but the only point is we need to refer where is the pom.xml file is. Usually the Hughes application is dividing into sub applications as per the divide and then conquer policy, and these sub applications are combining in the parent project as a single PAR file. That is the reason we have taken these applications inside this middle app parent. Okay, these can also be taken at outside, but the only point is we have to refer the pom.xml file properly. We have to refer the parent pom.xml file properly. Got it? Huh?
Yes, sir. And why this parent is type is POM, not var?
Yeah, why the parent type is the POM? If this is referring as a parent for the all the modules which are independent applications. So if this will be a var, then what will happen? The middle app backend and front end need to be locate that var from the M2 folder. So then what will happen? Backend will be created as a separate var file. Front end will be created as a separate var file. Backend will refer the parent and then front end will refer the parent. but backend and then front end are not packaged in a single var file called middle app parent. That is not possible. So to build a single var file for the middle app parent, by combining this backend var file and then front end var file, we are taking this middle app parent as a var file, form file. Okay, so let us run it and then we will see whether we will get the single var file or not. Single var file artifact or not. Let us check. Okay. Yes. Now what happened? Middle app parent build success, and then the middle app parent front end success, middle app parent back end success. Now go here, just refresh, and we got the target here. Yes, target var is build, and then we got the target here. This target var also build, but here we have not seen the target because the packaging is what PAM file. Okay, for a while, let me give here var also. Packaging is var. Let us give just for a while. Yeah, project builder. See, packaging with the value var is invalid. Aggregator projects require PAM as packaging because we are aggregating or we are combining all the projects into a single project, isn't it? That is the parent project. So that's the reason. We have to take this as a PAM. Now, what is happening when the parent project is building, right? So we got the target for the parent project also. Okay, so we got the target for the parent project also. Now this target, if we can go to the web resources, meta-nf, Marvin, DSoft, middle app parent. So form.properties. We need to use one more plugin also to generate a common var file. But if we can see carefully, when the parent project is cleaned, all the projects were cleaned. When the parent project is built, all the projects were built successfully. That means what? The parent project is orchestrating the sub projects, and the sub projects are grouping together as a parent project. That means what? We have divided the parent project into all small sub projects where each and every sub project is one module, and again we will conquer them, the all sub projects, into a main project. So for that we need to use one plugin in the pom.xml file to also generate a common var file for this middle app parent. Got it? So this is called the divide and then conquer policy. So to this divide and then conquer policy, we will apply few principles and then the characteristics, and then we will make it as a microservices. For example, now I am cleaning the parent project. Just let us see what will happen. I'm cleaning the parent project. Yes, all the three childs, I mean the parent plus the childs also get cleaned. Just refresh. Yes, the target is gone. And just refresh the front end. The target is gone. Target is gone. Now let us again rebuild. What will happen? All these two applications, like the front end and then back end, were also built along with the parent. So parent will be built, front end will be built, back end will be built. That means all the modules of the application will be built and then they combined as a single application called middle app parent. So middle app parent have the modules called front end and then the back end. These two modules are built separately because these two are two different applications, small applications, and these different applications were grouped with a single application called middle app parent. So this is called divide and then conquer. Divide the middle app parent project into sub projects and then conquer the sub projects into a again main project. This is called divide and then conquer policy. Are you clear with this divide and then conquer? Any questions in this divide and then conquer?
Two questions. The first one is, will there be any code in that parent source directory? Will there be any code?
Okay.
Or it will
So,
be always empty?
Yeah, can be. So if we can see this SRC and if we can see this SRC. So the parent project packaging type is PALM. So as it is the PALM, the parent don't have the code in the SRC. Parent don't have the code in the SRC. Okay, because its packaging is not var, its packaging is a PALM. That means what? It need to aggregate all the projects into a common or single project. So when the aggregator we will take, then the packaging type should be PALM, not var. Clear?
Second, sir, if it is the POM type packaging, then how will we required var kind of thing to deploy that project somewhere, right?
Correct. So
We will be
the
deploying
meaning
parent
these
somewhere, right?
all
So,
the sub projects need to be built as a single. Correct. So parent need to be built as a var file, or parent need to be built as a some jar file, some artifact. So parent we will deploy so that all these modules as a separate applications get deployed. So right now we were not use the plugin to generate such a parent related var file or jar file. What I'm saying is, as we have used the modules, if we take some plugin, there are some plugins, var generator, jar generator, Marvin plugins. If we take those plugins, that plus parent, though the packaging type is PALM, Otherwise, what we can do, we can take one more parent, for example, middle app parent. This is the middle app parent, right? Or let us rename it as middle app, and then take it as a var project, but contains the modules here. What I mean to say is another level of parenting is what we need to do. So that will give us the var file, right? So let us go to this pom.xml file. What I mean to say is, when we say this modules by modules, so if I take this var, right? Now let us see what it is giving us. It is giving us the project builder packaging the value var is invalid. Aggregator projects requires the PALM as packaging. That means what? This modules by modules we were taking, right? When we take this modules by modules, this packaging should be pom.xml file, should be PALM actually. But when it is PALM, till we can build a var file or jar file for this parent if we take the plugin. So that plugin will makes it to be create a common or a concrete var file which contains the var files of these two, backend and then front end. Got it? Huh?
yes,
May I
sir. So
answer your question?
that yes, sir. That packet plugin will be combining all the var of the modules.
Correct. Exactly true. So the concept here, what we are doing, parent, we are dividing into sub projects, and in the sub projects, we are implementing our logics or our features or our business. And then the sub projects are again grouping together as a main project. And then the main project is deployed into the application servers. So this is called divide and then the conquer policy. Clear, folks? Divide and then conquer policy is clear, right? How we will do usually, right? Is it clear? Any questions for me in this divide and then conquer policy? Great. So if it is clear, now let us go back to our microservices discussion. So what are our microservices? Our microservices are also follows the same divide and then conquer approach, because many organizations such as Netflix, Amazon, and eBay successfully used the divide and then conquer technique to functionally partition their huge monolithic application into smaller atomic units or small applications, each performing a single function. So these organizations solved a number of issues they were experiencing with their monolithic applications. So whatever the monolithic applications having the number of issues, those issues were resolved when they were divided their huge application into small applications. So following the success of these organizations, many of the other organizations also started adopting the same, the divide and then conquer as a common pattern to refactor the monolithic applications. So later, evangelists termed this pattern as a microservices architecture by applying the set of principles and then the characteristics to this, divide and then conquer technique, right? So that's how the microservices are came into the picture in the year 2014. The year 2014. Clear? So divide and then conquer policy. One moment, folks. Just a minute. Fine. So the divide and then conquer policy is followed by these giant companies, and they were resolved a lot of issues with their monolithic application. Monolithic application meaning what? All the modules inside a single application is called monolithic application. That means this is called a monolithic application. Now you can see all the modules are inside a single application, and when we build this application, we will get only one single var file. So if you can see the target, we'll get only one single var file, which contains all these modules inside this var file. And this var file will deploy in a single process called Tomcat process. So that is called the monolithic applications. So monolithic applications have a lot of issues. Those lot of issues yesterday we were seeing, those lot of issues will be resolved using this divide and then conquer technique. Later, the evangelists named this divide and then conquer technique as a microservices architecture. By making this divide and then conquer technique as a common practice, they termed it as a microservices by adhering a few principles and the characteristics. So by adhering few principles and characteristics on the divide and conquer technique. Okay, so by applying few characteristics and then principles on the divide and then conquer technique, they were termed the divide and then conquer technique common practice as a microservices. So microservices are what actually is a technology. Microservices is a program. Microservices is what actually? Microservices are architectural style, like however REST design is an architectural style. Similarly, microservices are also an architectural style. So there is a architectural style, architectural pattern, architectural principle, right? Architectural principle, architectural pattern, and architectural style. There is a difference among these three. However, we'll discuss this topic when we discussed about the RESTful web services in the maybe coming up sessions. But microservices are also a architectural style. It is not the architectural pattern, or it is not the architectural principle. It is an architectural style for building the applications as a set of smaller business components, which are autonomous, self-contained, and loosely coupled. This is what exactly the definition we were written yesterday. What are microservices? So what are microservices? Microservices are loosely coupled. Microservices are loosely coupled, a small tiny applications which will be self-executed, independently deployable, and autonomous. So these are called microservices, right? So tomorrow, let us see the microservices characteristics and then the principles. That's all for today. And tomorrow, let us understand the microservices characteristics and then principles. Then we will start our first pattern called decomposition pattern. So decomposition pattern, again, we have to study the bounded context, domain-driven design principle, and then let us apply the decomposition pattern with the triangular strategy. So those things we will see. But tomorrow, let us try to understand the microservices principles and then characteristics, and then try to understand the microservices with the honeycomb analogy. Once all done, then let us start implementing our first pattern, that is the decomposition pattern, how we can decompose the already existing huge application into a smaller microservices. That's all for today. Any questions for me?
So you have shown that parent module will actually, sorry, the project would actually hold the sub modules. So it can
Correct.
also accommodate other dependencies, just like what we have in Spring Boot parent project. When we open it, we actually find out independent dependency jars available inside that. So is it holding the same structure out over here? We can add some kind of a common dependency out over here.
Yes, we can add. That is the whole and purpose basically of this parent. We can add the dependencies which are common to all the projects, like front end, back end. For all these modules, whatever the dependencies we will add here, those are common. So that is the idea. Rather, why we use this pattern divide and conquer technique. For example, I want to use one dependency. Let's say dependency by dependency. Here, let's see quickly group ID, org.spring framework, and then the artifact ID. Let's use the spring-web MVC, and then let us use the version 4.3.18. Okay, now assume let us save it. So this, whatever the dependency we have taken here is common for the front end, and then the back end will be derived automatically to the front end application and also to the back end application. Got it? Yeah.
Can add Kafka also, sir?
Sorry, what is that?
Can add it Kafka.
Kafka. Okay, so if you can see these, what is that? The syllabus. Yes, syllabus. There is one pattern called event-driven patterns. In this event-driven patterns, in CQRS, let us use the RabbitMQ, and in Saga pattern, let us use the Apache Kafka and also the Oxon server. So we will use the Apache Kafka here in this event-driven microservices. Yes, Apache Kafka will be there because I was at the time of the Spring Boot microservices course started, I was committed that the Apache Kafka also I'll explain, because in our architecture, production architecture, Apache Kafka was there. So our production architecture, probably most of you guys might know. Just in case, would like to show you the production architecture. Just in case, it won't take much time. In 2 to 3, yeah. So production architecture, MS Cloud, yes. This is our final production architecture. So that production architecture having the Kafka also, RabbitMQ also, right? So it will be covered. Just let it open. Just let it open in a moment of time. Okay, any more questions for me? Any more questions?
Sir?
Yeah.
Topic is covering from the Spring Boot or microservices before.
Which one? Docker?
This topic, yeah, microservices patterns.
No, I didn't get your question. So microservice.
Microservicing and Spring Boot or microservicing. The classes go before no, sir. In the classes or this topic also covering.
Meaning the Docker you are talking?
Yeah.
No, Docker won't cover in the microservices patterns. Docker won't come. Okay, Docker will come in the Spring Boot microservices batch, guys, but Docker won't cover in the microservices pattern. So that is the reason yesterday I was published the course content. Whatever the course content is here, all this course content I'll explain, meaning we will implement practically all this course content. So seven patterns, meaning here see resilience patterns is a group of sub patterns again. So these whatever the course content I was published, each and every concept in the course content I will explain. So even bulkhead patterns also let us implement. Any questions?
Sir, one question.
Yeah.
Will this
Okay.
this pattern will be part of microservices, or microservices will start after this completing patterns? What exactly, how it is?
No, microservices is, no, these are all microservices patterns we will apply on top of the microservices, because the microservices we gonna develop are having issues,
But
architectural.
sir, sir, you can show us by deploying on microservice in Docker and Kubernetes, right? In one lecture only. That will help us a lot.
That will help, but I was not able to commit it right now, at least for the microservices patterns folks, the
Okay.
end-to-end. But I will conduct one free weekend workshop, because however we are doing the same process in the DevOps batch. So what I
So
can
DevOps.
do,
Oh, all right. DevOps batch is already in progress.
yes, DevOps batch is already in progress actually. So
Okay.
there we gonna deploy whatever the microservices we implement here. I will give these microservices to the DevOps folks. So
Okay.
they will write the Jenkins jobs, and then pipeline they will write. Through the pipeline, these patterns, meaning the microservices, will be deployed. That I will explain one Saturday or one Sunday. I will take one workshop, free weekend workshop, and then I will showcase that.
All right, sir. Sir, can you ping, I mean, some admin or anyone ping the yesterday videos and today videos, because I joined around 10 minutes back only this class.
Mm-hmm.
So, yeah, so
Yeah,
that
yeah.
will help. Yeah.
Yes. They will actually, whoever joined, right, for this demo, while joining, you might have given your email address, isn't it?
Yes. Yes.
Yeah. For that email address, our team will send the email by mentioning the links of this demo recordings. Yesterday one, and then today's one, and tomorrow's one, and then day after tomorrow. Four recordings you need.
All right, sir. Thank you so much.
Yeah. Okay, folks. Thank you so much. See you tomorrow at the same time, that is 7 a.m. Thank you so much.